get you started up. Hope we're all doing well. All right, I don't think I have anything I need to announce. So let's jump into Discord, see if any of the usuals are around, the usual suspects. And regardless, we'll get started on some questions here. I feel like I'm forgetting something. I don't think so, though. Oh my god, I literally... Is it number 9? Yes, number 9. Oh, it's 6.9. We have to do this one. Maybe it's the lack of music, but I don't usually play music for this part. Negative Plasma, the meme machine. How's it going? And the first machine. Okay, you know, it feels too quiet. Listen until and if someone hops in. Let's get some music. I'm doing good. Oh, hey, Fembucks.
Hey, Don.
How's your Saturday going?
Good so far.
Good to hear.
Give me 2 hours, I'll let you know how it's going.
Yeah, fair enough. Was the scoutron on the usual spot, and looks like the next one I had keyed up was a 1-star problem. Consider 2 circular rings of copper wire. One ring scale divergent of the other twice as large in regards radius, cross-sectional radius. If currents around the ring are driven by equal voltage, this equation might not be... I need to see how they got this equation again, but if the currents around the rings are driven by equal voltage sources, how do the magnetic fields at the centers compare? Now, it's interesting they say equal voltage sources, not necessarily equal currents. Hey, Twist Memes, bro, touch grass for real? Why would I touch grass? It's dangerous. So they say, do we have to be worried about the one ring being twice as thick? Does that affect what current goes through it from the same voltage source?
Don't we have to go back to like resistivity and conductivity and all that?
That's what I'm wondering, yeah. Because the
I want to say
resistivity,
yeah,
like it
has
depends
to
on
do
the
with
area.
cross-sectional. Yeah.
Oh, I don't know thermodynamics, Twist Memes. I've never taken a class. Where do we talk about conductivity? Maybe in electric currents? Okay, yeah. Thickness, length, and windings all make quite a difference, Negative Plasma says. Okay. Okay, so R is equal to rho L over A. And rho is conductivity? No, resistivity. All right, because R. Resistivity. I probably spelled that right. I don't know.
Looks good.
Okay. I'm not sure what branches are twist memes, but I've just been interested in this in going through this E&M book. Um, we'll switch topics probably in the new year. If not potentially sooner, but so if I equals V over R and the voltage is constant, but if we increase the area in the larger ring, we're decreasing the resistance? I guess that makes sense.
We're decreasing. Let's see. Oh, but the length is going up, isn't it?
Ooh,
The area goes up, but the length goes up as well. So
good point.
we have to
So
worry about like current density or anything like that.
I don't imagine. It's not for this. I'm just trying to work out like what the if we can work out what the currents are. I think we can use that 6.54 equation. I
Yeah.
don't really got to where it came from, but I don't imagine we have to worry about the current density.
Yeah, believe me, I don't want to worry about it. I'm just wondering if we have to.
Hey, Obi.
You know what it's making me think of? I was just helping a engineering student yesterday with a fluid question from fluid dynamics.
Oh,
And it turns out that if you've got a tube like that and you got fluid flowing through it, the velocity, right? The velocity of the fluid is larger in the center and smaller at the sides, which kind of makes sense, because the sides are causing friction or whatever in the fluid flow.
oh,
And I'm wondering if there's the same thing with like electrons flowing through these rings. So if we got like a higher current in the center and a sort of a smaller current at the sides, but maybe, I don't know. If that's the case, I don't know how to
um,
deal with that problem anyway. So maybe let's just keep going with what we got. I like this.
yeah, I don't have to worry for this problem. That's interesting. I think the book said at one point that wires do have like a static charge on the outside,
Yeah.
something like that, and that might be like the extreme case where the friction is too much. I'm not sure though. Um, so I guess if I1, we can just set it to be like A1V rho L1, and then I2. So the cross-sectional area is 4 times as big because it's twice the radius. So 4 times A1. And then the L, well, the circumference is linear, so that's just 2 times L1, I think.
Okay.
It's 2 pi r. Yeah. So overall, it's twice of I1. And so, and it feels at the center compare. So I guess BZ1 is just mu naught I over 2. They don't give us a specific letter for the radius, do they? So we can just keep the B. BZ2 is 2 mu naught I. What letter did I draw? Oh, that's just a 2B.
Wait,
Okay.
wait.
Oh, yeah?
What does that lowercase b stand for?
I think
Now
it's
that
the
I'm looking at it,
radius of the ring? Like a not cross-sectional? Current filament... Yeah, it's the radius of the ring.
okay.
Um, Maybe it's a bit more. I want to group the high with the 2 up there.
So those will change too, won't they?
Right. I think I was gonna put another. I was gonna put like another 2 in the bottom, I guess, for 2 times 2b.
Okay.
Oh, so do things come out to be the same? U naught
Huh.
I for 2b. Easy one. Okay. Are you good with that, or before I check the answer?
Yeah, let's think about
Oh
why.
yeah. Okay.
I'm good with it. I want to
Good
think about
question.
why. I'm trying to imagine I'm in a little, it's a spaceship. It's like a toroidal spaceship in outer space, and I'm like in a little spaceship, a small spaceship, and I'm flying towards it, right? Towards the middle of it. And so it's like looming in my perspective, in my vision, and I'm measuring the magnetic field as I go in. So maybe that's why it doesn't change. Like if
Mm.
everything gets scaled by the same factor, it doesn't change.
Yeah, because we've increased the current by the same amount we've increased. It is weird. We have this like double. We've accounted for the radius twice. I feel like with both the current and the b. Um,
I mean, are we sure about the applicability of 6.54 to this question?
I've been known to pull the wrong equation before. That's a good question
Because
to
when you
ask.
brought it up, I didn't really recognize it, but I saw where you got it from, so I guess it's fine for this.
Yeah, I don't think they consider the thickness of the ring, but
Circular ring of radius b.
I think a thick wire is the same as a thin wire as long as you're not like inside the radius of the wire and we're not.
Oh, that's right. They did something like that at the start, didn't they, of the chapter?
Yeah.
Hmm.
So I did
Okay.
pull the simpler version of the thing, whereas it's right at the center rather than on the axis. But I think that was their question.
Yeah, yeah.
So yeah, I think it applies.
And there's no problem with just multiplying all these dimensions by 2, right? Because what I get concerned with is the hole in the middle, but I don't think it matters because you could imagine like that hole was metal as well, and like sort of like replace the hole with metal and then zoom in and then cut out the hole again, and everything should scale by the same factor of 2, I guess. Or at least every length should be doubled and every area should be like quadrupled. So it seems good.
Okay. Hey Rex. Oh, was it 6.9? Okay. Let's see. Okay, we did grab the right equation.
Good.
At least for the resistance. Resistance is half. So voltage is the same. The field of the center is the same. Okay. 6.54 is the same one that I grabbed. Okay. They don't have any extra remarks or anything about why, but so we did it right.
Okay, great.
Um,
Nice little confidence builder.
yeah. All right. I had tenfold. This is a 2-star. Two parallel rings, the same axis, and are separated by a small distance epsilon. They have the same radius a, they carry the same current I, but in opposite directions. Consider magnetic field at points on the axis of the rings. The field is zero midway between the rings because the contributions of the ring cancel. And the field is zero very far away, so must reach maximum value at some point between. Right. If you could have done a problem like this for electric field,
Yeah.
So we might be able to take this equation 6.53 and just, I guess, take two versions, but, well, one is like a z plus epsilon. So well, that's the same direction. That's the opposite direction. Twist Beams, the name of the book is in the description of the YouTube stream, but it's also posted in my Discord, the actual like file. So is our, I guess we could just take the 6.53 as I guess our radius is A.
Yeah.
And this will be nearly the same thing, but
That's also an A on the bottom.
oh gosh, you're right. So 3/2. I think we do a minus, and then instead of z, we have z plus epsilon.
Okay.
It's my theory.
Would it be easier at all to, would it be easier to have the top ring be at epsilon over 2 and the bottom ring be at negative epsilon over 2?
Oh,
I'm wondering if that symmetry would make the calculating the equations a little easier. Maybe not.
it might. Like, how do we want to use this approximation? Epsilon is much less than A.
Oh no, is it going to be a Taylor series?
Oh, it could be.
You know, I saw a problem. I saw in the you've been going through the blue book of Morin, right?
Yeah.
And I was going through that the other day, and I was doing a problem from chapter 2, I think. I forget which one it was, but then in the answer it said something about a Taylor using a Taylor series.
Oh, yeah, I did that one.
Yeah. Now I was like, okay, let me think about this. I tried to use a Taylor series to do it. I couldn't. So, well, you know what I did? I rationalized the numerator and I got it that way.
Oh, I first did it with Lobitals, and then I did it the Taylor way.
Did you get, oh, you got it the Taylor way? Okay. I seem to have this inability to work out like how to do those Taylor series approximations.
I did have Cook uh, coaching me, to be fair, but in the back of the book, they do give, and actually, they do give the same Taylor series in the E&M book too, but it's like for root 1
Oh,
plus x, I just use the first two terms and plug those in.
oh, look at that. You got a PDF with the table of contents. Mine came up and it didn't have the table of contents. I don't know why.
Oh, I can send you this version if you want it.
I mean, sure, yeah, throw it in the Discord later or something if I'll ask
Okay,
you for it later.
sounds good.
Yeah, I read that appendix. Yeah, that was some good stuff. So you're saying you used
Okay,
1325? Yeah.
right,
That's the one
yeah.
I was looking at.
It only did the first two terms.
Yeah. I still didn't know how to do it because I had a fraction that had a zero in the denominator and the numerator. And I'm like, well, how's that going to get my zero out of the denominator? Anyway, I'm sorry.
Uh,
I'm getting us off topic here.
no, no worries. I don't have the file anymore, but for whatever reason, I forget why, but there was a way to make it fix the issue.
Yeah.
Um, that's not like okay. This is kind of an annoying thing to take the derivative of. We can factor out a whole bunch of constants, I guess.
Yeah. If I remember rightly, isn't the nice way to do this like you get a common denominator?
Is it?
I don't know if that, I don't know. I don't know.
Hmm.
They're
I mean,
both to the 3/2 power.
uh, what's up?
I'm just thinking they're both to the 3/2 power. So I don't
Yeah,
know. I guess we just differentiate, right? And just get through some of that messy algebra.
I guess so. Maybe we use the approximation later.
Oh yeah, working the approximation E much less than epsilon, much less than alpha.
2z. I guess we're multiplying by 3 over 2. Negative 3 over 2.
We had Z, if we had Z plus epsilon over 2 and Z minus epsilon over 2. Hmm.
Um, multiplying by minus 3 over 2. So that becomes a 6 over 2. Okay, I think this derivative is okay. I can cancel the 6 and the 2's, but I guess let's do that. Three, 3. I
All right.
guess? Yeah. We said equal to 0?
Yeah.
Uh, I still don't see how we... Epsilon is much less than A. I'm still not sure how we're supposed to use that. We could ignore the coefficient though, and I guess we need to multiply through by the denominators. So we get minus 3z a squared plus c plus epsilon squared to the 5 over 2. 3z plus epsilon a squared plus z squared to the 5 over 2. Solving this for z is not pretty.
Um,
If we like, the only thing to do is like multiply out the z plus epsilon squared, but I don't think it's really gonna do much for us.
yeah, maybe I'm just still thinking about this idea of change of making a change of variables from z to like z plus epsilon over 2.
Oh, yeah,
You know, something like that, so that everything can be,
a lot more symmetric.
yeah.
We definitely can. I mean, yeah, I mean, that at this stage, it might like, uh, that might make it more clear, yeah. Oops. So, that does change the derivatives. Maybe if we're going to do this, we need to
Would it?
go back.
Wouldn't the derivatives be? I think the
This
derivatives would be
first
the
one, oops.
same, wouldn't they?
This numerator should be, it needs a minus epsilon not over 2 for the first term. I don't think it's that bad to change. Just a couple of lines. Squeezing it in. Because it's gonna mess up the chain rule on this line that I'm working on now.
Hmm.
That becomes plus epsilon over 2. It's these weird 5 over 2 powers that are bugging me. This one needs to be minus epsilon over 2. Okay.
Ah, yeah. So now let's see if we add the first term over. Oh, no.
Can there's got to be something we can do here. What does it look like if we multiply out the thing inside the 5 over 2? We will get a squared plus z squared plus epsilon z plus epsilon squared over 4,
Yeah.
which, I mean, we could throw out the epsilon squared over 4, I guess, but... Oh, does that factor to a perfect square then?
Ah, so you're saying we can throw out the epsilon squared over 4. Because if we could,
Oh,
well,
hmm. This thing in the middle is nearly... Oh, wait, well, there's an epsilon. No, never mind. If we could justify that it's a perfect square approximately, that'd be nice.
yeah. So what did they say? They said work in the approximation epsilon much less than alpha, so, or a. So we're assuming the radius of the ring is a lot bigger than the distance between them. I mean, we could move the first term to the right side. We could square both sides to get rid of the,
Oh, yeah.
but then
Okay.
we still have this fifth power to deal with.
It's kind of wishful thinking, but I'm wondering if the one with the z minus epsilon looks any cleaner. No, it doesn't. Okay. I guess let's at least look at what you're saying. Forgot the... Oh, wait. I just started writing something random there. Z plus epsilon over 2 times a squared plus z minus epsilon over 2 squared 5 over 2 equals, and then the first term.
Oh, this is interesting.
Okay, so yeah, if we square things from here, fifth,
Oh, this is looking cool now, actually. Because you know the z plus epsilon over 2 squared and the z minus epsilon over 2 squared are just changing sides on both sides of this equation, right? So it's kind of like x times a squared plus y to the fifth equals y times a squared plus x to the fifth. If you see what I mean, there's some kind of a big symmetry there.
I didn't quite follow the things you are like like what you said with x and y, but
Or
I
we could
can
even
see a symmetry. Yeah.
do we want to divide out a squared from inside those things? Would that help?
Hmm. That could get us at least like something with a mixed in with epsilon. Yeah, if we factor the a out from the inside of each of these. Because I was just wondering if we can somehow justify turning the z minus epsilon and the z plus epsilon in those into just z's. But that might be a better way of accomplishing the similar thing. So if we take an a squared completely out, it becomes an a to the 10th. So that becomes a 1. And so if it comes z over a minus epsilon over 2a squared, I think is how this works.
Yeah, this looks right.
Okay. If epsilon is much less, well, aren't these fractions big numbers then, I guess? I don't know if that would help us.
Well, those fractions are small numbers, right?
Oh, you're right. Oh, okay. And maybe now we can throw out, just like say they're about 0. Oops, I just said the wrong key. So,
If we throw them out, we're just going to get, I don't think we can, because if we throw them out, we're just going to get z plus epsilon over 2 equals z minus epsilon over 2.
is that a bad thing? That's maybe
I mean,
like
if it's right, it's not a bad thing.
that's the key now, isn't it? Um, well, so we expect there to be 2 maxima. Are we? If we did throw them out, do we still? We might only get 1. It is. I don't. I mean, I guess if we subtract it back over, no, we could still get 2 maxima because they don't have to. We don't want to divide them out. We could subtract the thing back over and start on factoring. So minus equals 0. And we factor out, I mean, the a we can just divide out, but I'll keep it in here for a minute. So over 2 to the 5th minus z minus epsilon over 2. Oops, that's not to the 5th, that's squared. Equals 0. And this seems like something. I guess the fifth power doesn't make much of a difference when it's equal to 0. So are we potentially getting 3 answers then? And we have to throw one out? Or no, this is negative. C squared equals minus A squared? That doesn't seem right. So maybe this approximation... I mean, I guess I'll see what happens with the other one, but... I'll just add in random squareds. What happens here? We get 2z epsilon equals 0. Well, that's not good.
Hmm. I don't like any of our answers.
Nope, me neither. uh, mm. I would expect there to be a 0 halfway between them, but that... Oh, well... So we should find a minimum, I think, halfway between them. So maybe
Okay.
z equals 0 isn't bad. But z squared equals minus a squared, that's definitely bad.
Hmm. I mean, that was the first approximation we made, wasn't it? Was throwing out that epsilon over 2a.
Yeah, so maybe you want to back up to that step.
Yeah.
I'm going to imagine that this can be deleted. Because it seems like we didn't do the approximation right. One more line up. Okay. Maybe the approximation, if we actually multiply that z minus a over epsilon over 2a squared out, we can throw away the one that gets squared. Wait, that's z epsilon over a squared plus epsilon squared over 4a squared.
Oh, yeah. Okay. I like that idea.
Okay, so yeah, we only throw out that term then.
Okay. On both sides. Yeah.
Yeah.
And then can we use like 1 plus x to the 5th? Let's see. Yeah, we could. Hmm.
Oh, well, is this a perfect square? Oh no, the epsilon is still there. And the a isn't quite right. Um, for a squared, and that one's plus z epsilon over a squared. Okay. Well, now what I would want to do is the same thing with subtracting one of the terms over and factoring. Do we get a different answer?
Well, but we can't really factor, can we?
We'll do the same factoring that I did. Oh, you're right.
What about yeah, so the left-hand side, right? The thing inside the parentheses with the fifth power on it. 1 plus z squared over a squared minus z epsilon over a squared. That's raised to the fifth power. So can't we think of that as like a big term and a small term? So couldn't we think of this as like a binomial expansion? Like so I'm thinking of 1 plus z squared over a squared is the big term.
Mm-hmm.
And then z epsilon over a squared is the small term. So I'm thinking we can let it be 1 plus z squared over a squared to the fifth.
Yeah.
And then what? Minus 5 times 1 plus z squared over a squared to the fourth times z epsilon over a squared. Does that sound right? And then throw out everything else?
Like you want to throw out every term that involves squaring
Yeah.
the epsilon over a squared? Hmm.
Yeah.
I guess so. Something to try at least. So what's the second term that we get here?
We would get plus
Minus.
5 or minus 5, yep. Times 1 plus z squared over a squared to the fourth power.
Oh, right. And then just one of the z epsilon over alpha squared.
Yeah.
And we do the same thing with the term on the right, but it'll be plus 5. Okay.
Yeah.
Let's write it out and see how that looks.
And I think you can safely get rid of all these a to the 10th powers if you want to.
Oh, true.
Because I don't think it hurts to.
A isn't 0.
Yeah.
And it'll never like give us an extra solution. I need brackets there.
I think there's a fourth power right here.
Oh, true. Forgot that.
Oh man, is this still going to be outrageously messy? When is this thing going to get nice?
Yeah. It's just that slight, like one's plus and one's minus. It keeps messing everything up. Well, this, do we get a cancellation? No.
Yeah, we could factor out 1 plus z squared over a squared to the fourth, right?
Yeah.
We get rid of all that.
Okay.
Yeah, maybe at that point we can grind through the rest of it. If we have to.
I guess this is probably why it's a 2-star rather than a 1-star. Trying to figure all this out.
You know, it's so funny. I mean, you know, you and I have degrees in math, but these physics guys, it seems like they know Taylor series better than we do. I learned Taylor series, but I never really learned applications, I guess, really. I mean, feels like it was theoretical rather than applied, everything I learned about Taylor series.
Same.
I feel like I never got in the trenches with Taylor series, you know? This is like getting in the trenches with the damn things.
Yeah.
That's why I feel like we're fumbling through this problem a bit more than we, because you know, when we look at the answer, they're going to find some way to get through this in 3 lines.
Exactly. I feel the exact same about Taylor series. I'm not at all comfortable with actually using them. Um, this is a difference of two squares, these last two terms, or factors, I guess. Or we could think of it like that. Oh, well, no, we're dividing them. No, never mind.
Yeah, I was thinking we could cancel that fourth power because that's the one that gave us like z squared is negative a squared, right? So that's, I mean, we could
Yeah, where we
cancel
don't get
those out
anything
from both
useful.
sides. And then what else can we do here to make this come out nicely now? Do
Well,
we multiply both sides by a squared to get rid of all the fractions? Or is that not a good idea?
I don't see why not. Oh, I made a slight error. Z squared over a squared there. Um, yeah, it's a quartic. It might not be the worst looking quartic, though, if we were to just try to multiply things out. But we can start by doing the a squared on each side.
That one was a plus 5ze.
Oh, thank you.
Yeah,
I
okay.
guess let's.
Let's think about if
Oh,
you expanded the binomials, right? You'd get z squared plus epsilon squared over 4 plus ez.
yes.
And on the other side, you get z squared plus epsilon over 4 minus ez. And so then we have on each side, we have kind of a real nice symmetry. So we can think about expanding everything, but instead of doing like 9 products, we can do 4 products, right?
Um,
In other words, we can think of each trinomial as a binomial plus a monomial because the binomials are the same on each side. And it's just those negatives that became positive
oh,
and vice versa. That's why I wanted to write it as z squared plus epsilon squared over 4, um,
oh yeah, it's a four, not a two.
and plus or minus the ze.
Right. I still don't know how we can use that to simplify the algebra, but that is like
Okay, so
interesting.
I'm gonna add some parentheses in here.
Go
So
for it, yeah.
I'm gonna add parentheses. Let me see. I don't want to mess up your work here. I'll put brackets, and then I want parentheses here, parentheses here. Probably shouldn't have put brackets here. Oh, I should have covered up that. There we go. Parentheses there.
Yeah, I guess probably want
Sorry.
some
Does that make sense?
parentheses there too. Yeah.
Yeah. So now everything that's in parentheses, you treat those pairs as like a unit. So let me see if I can explain why I think it's going to work. It's going to make things nicer because if you think of this times this and this times this, right? They're going to
Oh,
cancel with this times this and this times this.
yeah.
Yeah, so we don't have to do all that stuff.
Okay,
We
we don't
can
have to care
just
about
do the
certain
first times.
terms.
Yeah, we can just do, instead of foiling, we can do first times first and last times last on each side, I think, because everything else will
Um,
cancel.
Wait, aren't those the ones that cancel?
I think it's the
Uh,
inners and did I say that
is
wrong? I
that
think it's the
one
inners and
times
the
that
outers.
one? Like it looks like these ones that I'm bracketing in
Yeah.
red cancel.
Sorry, Don. Yeah, you got it. You got it.
Okay.
They will cancel, right? I forgot about this is a equal sign. Yeah.
Oh yeah.
Sorry.
um, so the ones we want to keep are the first one times the fourth one. So minus 5ZE. The second one times the third one.
Thanks for doing all the writing.
No worries. Um,
What I really should do is just off stream, I should get an Excalibur and just mess around with it for a few hours so I can work how this works, you know?
oh, yeah, I mean,
Fun.
it's not too bad once you learn its quirks.
Yeah.
Okay, and so these are going to add with each other. So,
Okay.
ugh, minus 10 z e z squared plus e squared plus 2 z e a squared plus z squared equals 0.
Oh, we
So,
get z equals 0. Z equals 0 is the solution, right? That's
okay,
what we were looking for. That's good.
yeah,
And then if we divide both sides by that z, if we factor that one out, we should get two more solutions, right? Because we got a quadratic here.
yeah. All right, so we get z equals 0 from that one, then from that one, minus 4z squared, and then the rest of these are just a constant. A squared is 0. Okay. Um, 5e squared over 4 plus a squared over 4.
5e squared plus 4a squared over 16. 5 to
Uh,
4 ratio.
a squared over 16 plus a squared over... Oops. I guess that is how that one's done. We can write this simpler, though. Take a 1/4 out. Oh, I guess it's not that much simpler.
I was thinking of taking out a 1/4 and putting it as 5e squared plus 4a squared.
Wait,
So,
what?
well, just getting a common denominator, I guess, is what I was thinking of.
Oh, yeah, true. But that would definitely be simpler. Okay. In this, the dimensions check out because those are two lengths.
Yeah, square root of a length squared. Yep, okay. So,
Huh.
is there anything else nice we can think about this? What about if the radius a gets really big? So
Uh,
so the z scales up linearly with the radius a, I guess. So if you double the radius, is that right?
well, you know what? If we are saying that a is much greater than epsilon, we could write this as approximately a over 2. We just axe the epsilon term.
Oh, okay, yeah. If epsilon was just 0,
That seems
Half the
convenient.
radius.
Uh, why would that be the maximum? I guess because the contributions from the ring that's farther away are starting to fade a little bit. I don't know. A over 2 seems like a nice clean answer, but I'm not sure why it couldn't be something else also.
Where the heck did that 5 come from anyway?
Um. Oh, the binomial coefficient. 5 choose 1.
Oh, yeah. Yep.
Hmm. Are there any other parts of the question? Not that I see.
Why does it say it must reach a maximum value at some point in between? Find this point. Weren't we trying to find 2 points?
I assume they're just like speaking symmetrically, or like we only have to care about one of them. Field of 0. Because I can't imagine this field not being symmetric with the z, or like, I guess like even, even though it's probably a
Yeah,
bad
I
term
mean, it
to
has to
use.
be, right?
Yeah.
Yeah.
Or I guess odd if they have opposite directions, but yeah. Wait. Oh, would it be like a very strong negative field on one side, maybe? Or like, very strong is relative, but it might be a minimum because they do have opposite directions where one is pointing up at a maximum, the other one's pointing down at a maximum, would count as like a minimum. That's my
Yeah,
guess,
yeah.
at
Wait,
least.
let's think about that for a second. So if you go back up to the picture you drew, right?
Yeah.
So if you've got, so let's say we had the top ring here with the current going like this. Then let's see, I'm going to use the right hand rule. So doesn't that mean the field's going down?
Um,
Right hand rule says, yeah, curl your fingers around the ring and your thumb points in the direction of the field, right?
I think so, yeah.
And so then if I put the other ring below it, uh-oh, I don't know if it's my computer or Excalibur, but
Excalibur is starting to slow down.
is it? Yeah.
Hey, respect.
Yeah, it just kind of crashed and came back. But let me
I
draw
don't
one more
know.
picture.
After this one, we can get a fresh one.
So if I had the other ring down here, oh, now with my fat pen again, then you'd have it up here and up over here. So in between, they should cancel.
Yeah. Like, I
Right in the
imagine,
middle, they obviously cancel by symmetry.
yeah, like I imagine the function would look, if you just grabbed it like, say like on the XZ axis.
Yeah,
that
let's do that. We don't need to think 3D. We can just do it on an axis. Okay.
imagine like one half will look like that and the other half will look like that.
Oh, I like this. Yeah, yeah. So we found the two
So
points we
there's
found are like those two. Yeah.
yeah, they're critical, but only one of them's a maximum, I guess.
Yeah.
Especially we did get zero. I guess that's an inflection point. Shouldn't have been z squared though.
What did they say in the question? The field is zero midway between the rings. The field is zero very far away. It must reach a maximum at some point in between. It probably just means the magnitude of the field, right?
Well, I mean, if it's zero, then well, yeah,
Yeah.
the direction wouldn't
But
matter anyway.
I kind of like the graph you did. Like you said, it's like an odd function, isn't it?
Yeah,
Because let me think, if you pick those rings up and turn them upside down, if you pick that whole configuration up and turned it upside down, the current would be flowing. The I1 going clockwise would become the I2 going counterclockwise or whatever. All right.
you're good with this?
I'm good with it. Yeah.
Okay. Respect. I'm not currently studying at a college. I'm applying though for grad school.
All right. Good luck. Yeah. Where are you thinking of going? Oh, you might not want to say on stream,
Uh,
but yeah, yeah.
I'll say I'm not opposed. I just like haven't decided how much I would keep from the stream, but I'm looking at schools like along the west coast.
Nice.
But and I'm gonna throw one in for physics as well because
Wow.
it's just
Wow.
cool.
Nice.
Yeah. Um. Okay, so they did do the z minus epsilon over two and z plus epsilon over two, so good call on that.
Okay.
Oh no, they do it in two
Uh-oh.
lines though, or three lines. Difference is simply epsilon times the negative. What are they doing? So they would have used a Taylor series for an even easier way.
Oh God.
I don't see how they're setting up this like 285 equation.
Yeah, I'm looking at it too. What did they do here? They said the difference is by definition, epsilon times the negative of the derivative of this function. So what is this goofy function in the parentheses?
Yeah, this
Oh, that is
isn't.
is that the formula you pulled up? Let me see.
Mm,
This formula is 653. It does look like the formula you pulled up. Oh, yeah, that thing in parentheses is what we started with, BZ.
yeah, but I'm confused why they have a derivative already when it's not. This is just b sub z. The difference is the epsilon times the negative derivative of that function.
Oh no, wait a second. Is this like the definition of a, oh man. Why do physicists know math better than I do? This is so depressing. You know, you get Dr. Cook and Fizzbuzz coming in here and schooling me on Taylor series, and now this book is doing the same thing.
Oh my god. Dude, it was on Thursday. Anders asked a question about posets just for fun, and Fizbuzz completely got the answer to it way before I even understood what the question was. It was kind of annoying. It's like, man, this thing that's firmly in the math realm, I can't even figure out first.
Well,
Ugh. Simply.
okay, so they're saying that difference is is the definition of a derivative of a function, right? Let's think about that. Because epsilon's very small, so we're
Oh,
saying we're doing like b of z plus epsilon over 2 minus b of z minus epsilon over 2, right? So isn't that epsilon times the derivative of b or something?
I
I think it
think that's
is.
what they're going for. Like this is maybe
Yeah.
the slope of a tangent line or something.
They get some answers slightly different from ours. We both
Uh,
came up with alpha a over 2, but we had,
well, I did throw out the leading coefficients. Was that the
oh, you
problem?
know what? No, I think we basically got the same thing. We kept another epsilon term. We had we had a squared minus 4z squared plus 5 epsilon squared over 4 equals 0. And they've got like a squared minus 4z squared equals 0. Yeah, on line 286, right? Line 286 there. They've got a squared plus z squared minus 5z squared equals 0.
Yeah.
So basically a squared is 4z squared. We had a squared equals 4, plus 5 epsilon squared over 4 equals 4z squared. So maybe we kept too many epsilons.
I guess so. Um, Either way, yeah, I'm glad that we got to the right answer at the end, and I think the maximum value, their exact values, without using an approximation at all. So I'm not too worried about not having that exact thing.
Well, yeah, we didn't do that, but
Um,
wouldn't that just be plugging a over 2 back into
oh,
the
you're
formula?
right. That's where that comes
Yeah,
from. I'm
yeah,
kind
I
of
guess
curious
we should have.
to do this with Taylor series another time to get some practice with that, but I, I still haven't quite figured out what trick they're using to make that so much simpler. Let me get a.
It's kind of like that, isn't it kind of like that epsilon is kind of like the h that we learn in calculus? You know, the derivative is the limit as h goes to 0. And we could just replace
Oh.
the h with that epsilon. And then if instead of going like instead of going from 0 to h, we're going from minus h over 2 to plus h over 2, something like that.
Oh my, that's like a cursed version of the definition of derivative. Like,
That's kind of what it feels like to me. I think that's what their argument was.
yeah. H over 2 minus f of x minus h over 2. And they had the minus in front, which is why we had to include the minus. Oh, I hate this, but I think, yeah. That's why they multiply by a negative epsilon. Wow. Who would, I can't believe. Oh my, that's kind of mind blowing, but I also hate it. Yeah, I think you're right.
So that's what they did. That's pretty smart though, you got to admit.
Yeah.
That's a nice little idea.
And that's another like just like that's like a math thing too. That's not even a physics thing. Annoyingly.
Yeah.
And then second Excel right here. Posted the link. Okay, I did get a download of the first one. Good. Okay, what's next? So we just did 10. Okay, this one. I think you were there when Henrik was asking about how a permanent magnet works, and something about like the electrons lining up and like spinning.
Hmm.
This feels like it's building towards that with this field at the center of a sphere can maybe it'll eventually become an electron spinning and generating a magnetic field.
Hmm.
Spherical shell, so it's not filled in.
Oh boy.
Um, Angular frequency omega around the diameter. Find the magnetic field at the center of the sphere. Interesting.
Hmm.
Um, so there is this kind of interesting. It's hard to draw a three-dimensional sphere, but like if we draw like a north and south pole,
Mhm.
the charges right at the top and bottom are just like staying in place.
Yeah.
Uh, I would this be a Biot-Savart thing? Because I imagine we need to get this angular speed translated to a regular speed.
My first idea is take the shell and slice it into just a bunch of rings.
Okay.
So that every ring is just a horizontal ring. Yeah.
Yeah. That second one try would be a bit narrower. Actually, maybe it's. I should put it just above.
Now, if we have a spinning ring with uniform surface charge density, is that the same as having like a stationary ring with a current flowing through it?
Oh, yeah.
That was my idea, but I don't know if it works.
Oh, that's really good because we know what a ring does. Um, yeah, we would want the field on the axis. So I would say we want this equation that we used just in that last problem. Something like it at least. I guess they'd have thickness dz
Okay.
that are essentially rings of current. Yeah, okay, I really like that because I feel like just by symmetry, this field can only go up and down. And so that
Yeah,
is in line with how a ring would do on its axis.
yeah.
Um,
So for each ring, we can also get B as a function of Z, right? Is that the way to do it?
yeah, I think so. Um, how was that? That's just like the x or y axis, and that's z. We want actually something like that if we're
Hmm.
integrating for that ring. So and z. So
Would polar coordinates be better?
he does have more. Uh, ooh, maybe.
Like instead of letting Z go from 0 to R, we could let theta go from 0 to pi over 2, minus pi over 2 to pi over 2, or whatever.
Uh, yeah, I could even see cylindrical being convenient too, because we might want to keep the z variable,
Okay.
but spherical might be the play too. I remember having that azimuth angle is more helpful than C. And that might be because we could use trig to get like that distance there, I guess.
Yeah.
So um if that angle, I think in math we normally use phi, but in physics they use theta. They
Oh,
like
wait a
haven't
second. Wait a
switched, but
second.
oh yeah.
Wait a second. Oh, wait a second, Don. Wait. You know what I just noticed?
What's
Check
it?
it out. Think about every point on that little quarter circle that you've drawn, right?
Mm-hmm.
Think about the function bz we're trying to evaluate. Look at that denominator, b squared plus z squared, right?
Yeah.
B squared plus z squared. Think about b squared plus z squared at every point on that circular arc. Isn't it constant? Isn't that isn't that just the radius of capital R? I think it is.
Oh. Uh yeah, every point is always r away from the origin because it's a sphere.
Because we're only concerned about the very center of the sphere, right? The field at the very center of the sphere.
Oh, so we could even use
So
the
B is the
simpler, like the other version of this formula potentially. Well, that might be too simple, but no, not this one.
yeah.
But like, or even just like the first version of the formula, like that small r cubed could be big R cubed.
Oh, yeah, there you go. That small r is just big R.
and then we'd be integrating over b
Right.
from 0 to r. That's so weird.
Well, let's see. We got to bring the. We also have to get the current I, don't we, for each ring? Because
Oh,
that's not going to.
yeah, different rates. Or the current is strongest on the equator of this thing. Or this is the fastest. No, it's the slowest. No? Yeah, no, it's the fastest. But has longer to travel.
How are we going to work out the current of one of these rings?
Um,
Are we just going to take the surface charge density times the circumference and just say, well, that's the charge,
the
dz, I guess.
circumference. Mm,
Like, let's take that ring around the equator, right? So the circumference is 2 pi r, and if the
mhm.
thickness of the piece is, well, then we would have dz again. So 2 pi r times dz times sigma would give us q, right? I should write down
Oh,
what I'm thinking.
shoot.
So,
Actually, that R cubed being big R might not be accurate now I think about it.
really?
Uh, it's not. Because for that equator, R should be 0, I think. Like, they're defining R as like that. I'm showing it on the stream. Like, it's like the hypotenuse of, well, no. Maybe, no, that might be okay. Is that okay? No, okay, no. I think it's okay. Never mind.
I think it's okay.
Yeah.
Because that picture you're looking at on the example, you're thinking of moving that test at point Z all the way down to the middle of that circle.
Yeah. Okay. And that one becomes B. Okay. Yeah. So we're good on that front then. Um, they were dealing with like sheets of moving charge, and they had a weird script J thing that I wonder if we're going to need for surface charge current.
Oh, that curly J.
Yeah.
Maybe.
I remember somewhat losing the thread when they were using that thing though. I remember.
I'm just writing down some ideas here.
Oh yeah, go for it.
So that could be the charge. I'm just thinking about the one ring at the equator for now. Let's say that was the charge. How would we get the current? Then the current would have to be the charge per second past a certain point, wouldn't it? So if it's angular frequency omega, how do I bring that in? Angular frequency is what? Radians per second. Coulombs per second. And 1 amp is 1 coulomb per second. Do I just multiply by omega? I guess I do. Is that all I do?
Uh, so sigma is charge per area.
Yeah.
Um,
So I took the
and
circumference
so
of the
circumference
ring
times the thickness dz.
times the
Oh,
thickness. Yeah.
and then omega is the velocity. Do we need like omega times r or something like that to make it not rotational? I guess like big R. I forget how you translate between rotational and not rotational.
Oh, yes. Yeah, sorry. All my R's got small. Why did I do that? That was not intentional. I fixed those.
Well, that might the the velocity definitely depends, or the translational velocity definitely depends on how big the ring
Yeah.
is.
Yeah. This was just the one at the equator, but yeah, I just was running through this to see if this idea seems to
Oh,
make sense.
well, actually, no. That might even need to be a small r that we because the circumference does get smaller the higher up we go. Unless we're only looking at the equator right now.
Yeah, I was just looking at the equator, but
Okay,
yeah,
then that's fair.
but yeah, as we come up, I'm gonna have to tinker with the circumference, right? And what else? Is that all I gotta mess with? I can keep the thickness dz, I guess. And omega's constant, right? Okay. So what's our variable we integrate over then? We want z, right? So we need the circumference in terms of z. So
Hey, nothing. We thought about spherical coordinates. We might have found an easier way, though. Potentially.
that's r. Little r, let's call that that. That's capital R. This is z. Oh, here we go. So it's little r squared plus z squared is big R squared, right?
Uh, okay,
So if I
yeah.
want to get, so this is R squared minus Z squared. So I could put that in for the radius instead of capital R.
Uh, we want everything with respect to. Oh yeah. Okay, yeah, that's good.
So 2 pi omega sigma square root R squared minus Z squared dz.
Now, I feel like omega is still a problem, but I do like this.
Okay, you think we might need to fix the omega?
Like I think we want like the tangential velocity, not the rotational. That just I think we've just never talked about rotational velocity for when it has anything to do with current. Actually, I don't think the book has talked about rotational velocity in general. I don't remember how we convert it.
I think this is right because I was just thinking of current being coulombs per second. So I don't want to bring in meters. I just want to think of how many coulombs flow past a point in a given second. So
Um,
I think I want omega because that's just per second, right? Like hertz, right? Hertz is revolutions per second, but omega is radians per second. I could mess this up because I tend to screw things up when they become angular.
uh, I mean, I'm even worse. Uh, what are well, okay, if we do keep it like this, what units do we have? Uh,
Yeah, this might be good.
we'd have charge. Oh, this would be charge per second with that. Okay.
Yeah, that's kind of how I tried to build it in the first place. I was just following the units.
I guess so. Yeah, we could integrate and pray. Do we have everything we need?
And if we
Um,
plug this in, right, because we need the b squared as well, but b squared is, oh, b squared
B, that's R, or the small R that you
is
just got.
r
Yeah.
squared. Yeah. Okay.
So we want to integrate minus R to plus R.
Okay.
Uh, let's put the constants out front.
Yeah, what's constant? Mu naught over 2 big R cubed.
U naught over 2. Yeah. And then I guess uh
And then we just got to integrate I times b squared.
yeah, okay.
Oh, I see. You're going to think of the 2 pi omega sigma as well.
Oh, no, I was just getting lost in the formulas to be honest. Those should come out front too, but this time I won't bite off more than I can chew with the mental math. And then we multiply by b squared. Okay, and that is r squared minus c squared. Easy. Okay.
Well, we got to, I think if we're right, then we're home free now. I mean, this shouldn't be hard.
Yeah. So pi mu naught omega sigma. We just got a party of Greek letters in the numerator.
Yep. Two's
Oh, is
company,
this?
three's a crowd, four's a party.
Yeah.
Yep.
Is this? It would be a trig sub, I think, but we can do a table of integrals.
Oh, look at that. Oh, wait. Yeah, what do we do here? Factor out r
I think
squared.
that's like a sine sub.
Yeah. That
Oh, are we
r,
not given this one?
that capital R is going to come out nicely.
Purcell and Warren actually want us to do some integration, or we potentially set it up wrong, but I feel like we didn't. Okay. So,
Goes r cubed times 1 minus z over r squared, isn't it?
uh, yeah.
So
And
the
if
r cubes can cancel now. And we can let z over
oh,
r equal, z over r can be either sine or cosine, right? 1 minus
oh
sine
yeah,
squared.
both should work. guess U equals C over R. I mixed up these letters, didn't I?
Wait a second. Wait a second.
Oh.
Z equals.
Wait, I didn't do that right. 1 over. Wait, so maybe I did mess up the letters. U
I
is
think you
Z
just
over.
won.
Yeah. Wait, sine. What am I doing sine of? Z over R equals sine U. That's what I want.
That's what I was thinking. Yeah.
Okay. There we go.
Wow, how do you move those things around? It's like they're made out of. You got some trick for
Uh,
moving things.
it's that. It's on like
Oh,
the
the hand
number
thing?
one. No, it's like right
The number
next to the
one.
hand, just like the cursor, and then you can like drag boxes and things. C over R sine U, and then okay, I think I got that right.
Yeah, it looks good.
Um,
Cosine
I guess the
cube.
bounds is minus pi over 2 to pi over 2, or you do that root.
And so we're gonna have
Nope, we don't have to divide. We just keep it as is. Okay.
R showed up again.
Yeah. Actually, that makes sense since we're doing this U sub. Like, if we don't switch the bounds back, we wouldn't get the R. So that's cosine squared to the 3 over 2, which is cosine cubed. Oh no, cosine to the 4th.
Oh, that's all right.
Uh,
Cosine squared equals, let's see. Cosine, oops.
oh, can we use 2 different like double angles, I wonder, and get a nice cancellation?
Cos 2 theta is um, uh,
Maybe
no.
not.
I'm not good at doing math on stream. Cos 2 theta equals
uh,
cos squared minus sine squared,
yep, that's one of them.
which is 2 cos squared minus 1.
Mm-hmm.
So minus 1. So I get cosine squared equals 1/2 1 plus cos 2 theta, right? That's right. 1 plus cos 2 theta. So we got that thing squared. So cosine to the 4th equals 1/4. 1 plus cos 2 theta squared, right?
Oh, okay, yeah. We're gonna have another cosine
And
squared to
then,
contend with, but yeah.
yeah, so we got 1/4 of 1 plus 2 cos 2 theta plus cos cos squared 2 theta. And then what's the cos squared 2 theta? It's going to be half of 1 plus cos 4 theta, right? Theta. All right, so that'll get us through 1/4, 3/2. Is that 3/8? Wow, I feel like I'm
Um,
screwing this up.
oh, for the one hat, 3. you get 3/2. Yeah, 3/8.
Okay, 3/8 sounds good. What's a half cos 2 theta? What's 1/8
Yes.
cos 4 theta?
Okay.
All right. Actually,
Okay.
you know what? Okay, was there a shortcut here? When we integrate cosine, we get sine. I guess we did need to do all this.
Yeah, thank you for doing that
Are you gonna have enough room?
annoying
How do I move
algebra.
it? I use number 1, right?
Oh. Oh, with complex numbers? Maybe not. Okay.
Dang it.
Oh wow, Excalibur
That
does
moves
not
it.
like moving big things at once.
There we go.
Oh wait. Okay. 3/8, 1/2 cosine 2 theta, 1/8 cosine. Okay, cool. Mu naught omega sigma r 3/8 u cosine integrates to positive sine. Uh 1/32 sine for u. Hopefully. This feels like it's going to be something weird. I guess some of these weird terms will cancel though. Wait, that's 0 because it's times 2. Um,
Yeah, all these signs are gone, aren't they? Because we're doubling these things.
sine. Yeah, the second one becomes 0.
Yeah, sine of pi and sine of 2 pi, those are all gone. Okay.
Okay, that cleans up then. So we get 3/8 pi squared mu naught omega sigma r.
Cool.
That's a result.
Should we check the units on it? What's mu naught times omega times sigma times r? Quick.
Yeah, mental math. Um, that is a
Is
good
it
thing
a
to check.
magnetic field? We're trying to find is it a Tesla? Yeah, it's a Tesla.
Yeah. So I guess we don't have to check the mu naught as long as everything else comes out to be current times or current. But what do we expect? We want a current per length, I think. Yeah. Current per length is what we want. So uh omega we can consider as 1/time. Sigma as coulombs per square meter. R, oh, the time seems bad though. Can we ignore the omega and be happy?
It's mu naught though.
Oh, I mean, I was kind of trying to match the rest of the thing. We can look at mu naught as well. Oh, it might have yeah, it might have time wrapped inside it. You're right. Mu naught. So the very last one. Tesla meters per area. Or
Good.
no, amp. I'm sorry, amp.
Good. We're good. We're good.
Okay, yeah.
Tesla times meters per amp because we got amps per meter right there.
TM per A. Okay,
Volts per
nice.
second is amps. Yeah. So it's a, well, I'll be damned. It's a Tesla. Three pi squared over 8 times all that, and it's Teslas.
Okay, that's reassuring. Didn't have to do anything else right before I look at the answer.
So a bigger radius means a bigger magnetic
Yeah.
field. Does
Oh
that
yeah,
make
that's
sense? A
interesting.
bigger radius means a bigger magnetic field. Why is that?
So you're farther away, but you do have a faster current and more charge because the density stays the
Yeah,
same.
yeah. And if
Um,
omega gets bigger, we're going faster.
yeah.
And if sigma gets bigger, we got more charge.
How does the formula for a solenoid look? I wonder how similar it would be. Because like the only real difference is these rings are getting smaller, whereas the solenoid stays the same.
They did solenoids in 6.5, yeah.
Yeah, so it's mu naught ni, for n is the number of turns per meter. I wish we could translate that to something similar to the sphere.
Hmm.
What would be um our n would almost be like, I guess, well, what's our current? It's a little bit hard to relate our constants to the n, I guess.
Yeah, because even if we let n be the number of rings we slice the shell into, they're kind of all different size rings. So
Yeah, it's hard to compare because this is a continuous sheet versus like discrete rings. You probably could equivalently consider a solenoid that just gets smaller. I don't know.
let's see if it's right.
Okay. 11 it was.
What do you think? You feel good
11,
about
yeah.
it?
I feel good.
Yeah.
That was a really good catch that these are basically rings of charge.
Don't say that till we see if it's right.
Oh, is that Theo Savar they're using? Yeah. I can't help it. I want to look at the answer first. Like what the result is. No, wait. 2/3 mu naught sigma omega r. So we have 3/8 pi squared, and we didn't make it a vector, but I don't think that's a big deal.
Oh, weird. So we
Huh.
just got the number wrong, huh?
Yeah.
Maybe our pies were supposed to cancel instead of multiplying somehow. Hmm.
Uh, instead of also, I just like fumbled at the end there. I don't see how though, because unless I mess up the bounds of integration or something, but I'm not sure.
Um, let's see.
Which I think if we needed to divide by something instead, but I don't think so.
Oh. 16/9 pi squared. 4/3 pi. It feels like we're out by a factor of 4/3 pi all squared.
Hmm.
Where would that come from? Where does that 16/9 show up?
Uh,
Oh, wait, 4/3 pi is the surface area of a unit sphere, isn't it?
yeah.
Okay, so there's something wrong with the,
Maybe the definition of our current?
I think there's something, you know what? I think there's something wrong with how I set up this current, right? Because I don't think I'm allowed to slice the shells up like that. Don't I have to take into account the
Oh.
like the little arc length of the piece of the shell I'm taking? Damn it.
Oh no, there was an example problem where uh you have like uh a sheet of moving charge and they show that there's an error in trying to divide it up into like rods of charge. Um where is that one? Okay, on page 304.
Oh no, you're kidding. Did I make that mistake?
That's I don't remember what the mistake actually is, but they do that you could potentially get into trouble slicing things up into they did rods for a cylinder, but I assume rings for a sphere. Maybe is it an equivalent mistake? Oh no, this is no. I think it's a different situation. Never mind. I wonder if the answer addresses this way that we might attempt to solve it.
So I think do you sort of see what I'm saying about where I might have made a mistake? I took a horizontal slice of that shell, right?
Mm-hmm.
And I said the circumference is 2 pi r and the thickness is dz. But the problem is as z goes from 0 up to r, those little slices become more and more sort of tilted, don't they? Like slanted. Don't I have to take that into account? Maybe instead of using
Oh,
z, maybe it would have been better to use theta. Like I was thinking polar and use r and theta instead of.
that could be because I look at the problem that they do have an extra r sine theta term that might make the difference.
Hmm.
The amount of charge. What do they get for I is sigma omega r squared sine theta. Oh, and we do z. What would z be, or what would theta be by our? Theta would be z over small r. No, I'm sorry. Small r over big R. And did we have? Huh. I don't know. it isn't something in how we are describing the current.
Yeah, I think the problem is how I split it up into rings. Because if I let the thickness be dz, right? If I let the thickness be dz, then as z gets closer and closer to the top of that sphere, I'm getting sort of longer and longer slices from the circular arc. And I got to bring that factor in. So what does that give me? Does that give me an extra sine term? It probably does. It probably gives me an extra sine theta term.
Yeah.
So, okay. Oh. So if I was to multiply this current by sine theta, then that would just be multiplying by z over r, right? Z over
Um,
r in that picture, z over big R in this picture up here.
well,
Kind of,
it. Oh, if you're making that theta, yeah. The figure they have in the book, theta is like the angle that's like just above it, like right there. But we could make it the other one if we wanted.
if we just let's just try it quick and see if I have you got a minute to
Yeah, yeah.
so if I multiply this by z over r, right? Let's see what that does to our answer. I mean,
It
we
does
can
simplify
just
the integral. That's for sure. You'll go off like we can go off to the right here and
yeah, yeah, go up. Let's go up to the right and see what that does.
um copy paste the original. Uh just put Z over big R. Okay.
Oh, because now we got a z there for a u substitution. That's nice.
Yeah. Mu naught pi omega sigma r to the fourth on the bottom?
Okay.
Like that.
That's good.
Um and so for the U sub, do we want to get rid of the R squared in the same way first? I guess we don't have to. We can say U is Z squared minus R squared.
Yeah, looks good.
So these bounds are weird with respect to U, so I think we're gonna need to unsub later, but that's okay. 1/2. u squared to 3 over 2 du. Okay. U naught pi omega sigma 2r to the fourth. So that's integrating u cubed, so we get 1/4 u to the 4. We'll unsub and then do the bounds. Our r's are going to go away entirely, I think. Well, maybe not. We do. Let's bring the
Is there a
1/4 out
problem
front.
here?
Z. Oh, I flipped.
Aren't we getting 0?
I did flip Z and R. There should be a
I was going to
negative
ask you about that just because I wasn't sure the
there.
negative sign was playing nicely with the square root.
That is why I was getting a. Actually, no, it's still like yeah. When I was trying to do the sub, I was trying to sub the bounds at first, and then I realized that that's not really working out. But this is still.
Aren't we still getting 0?
How's that possible? Is this function odd? It is.
Yeah, I think it is.
Should we do it 0 to r and multiply by 2? Would that fix it? Well, no, it should just work though. We shouldn't have to do that. Right now we're getting everything is canceling and it shouldn't be.
Hmm.
Dang it. I wish they did it with respect to theta and it is clean, but I almost wish I could see it with respect to z in the answer key. Yeah, there should be a way we can modify what we did to make it work.
Yeah, the theta was the right way to do this.
I really like that idea with using the formula for rings, but I wonder why
It'll
they go to
still work, but
BSVAR. Yeah, I mean, maybe there's still some other term that we're missing here. Because they do set up their current a little bit differently. Like they said that, I mean, well, they're using VOR, so they do need that V more explicitly, but they do say that V is omega times r sine theta, and that's what I was trying to like figure out. If that like matters for the way we set it up, but I don't know. Relentless AO, thank you for the follow. I don't know.
let me just look at what we had again. We had
Oh, sure.
3/8 pi squared, right?
Mm-hmm.
We had all the right constants, mu naught omega sigma r. We even had them in the right order. It's pretty cool. I like
Yeah.
that. Because you know that order is important. But
Mm-hmm.
3/8 pi squared, and they had 2/3. right? So 3/8 pi squared versus 2/3. Yeah, so if I multiply that over, I get 9/16. Yeah, I get 9/16 pi squared, which is 4/3 pi, the whole thing squared, right? That's why I think when I see that, that's what's making me think my method was okay, but I screwed up with my parameterization of the surface of the sphere, right?
Yeah.
I think that's what I did wrong. And it's just because I wasn't taking into account the angle changing as you're going from the equator to the North Pole. I think if I redid it with a theta in there, I could get it.
Yeah. I'm not sure what else to add though. But
I thought that
I
z
don't know.
over r would work because I was thinking like as wait, is that z over r wrong? Wait, Don, am I wrong? Z over r is not what I want, is it?
So I was wondering
I
if we wanted
wanted to get.
small r over r.
Oh, let's try that. Is that the way to do it?
I mean, I don't know,
Yeah,
but
small r over r. Because when you're at the equator, we were good, and that's when the two r's are equal. And when you're at the North Pole, no, wait, when you're at the North Pole, maybe it's.
I'm just willing to throw shit at the wall and see what sticks right now.
Okay, good. Let's try
uh,
it. It would be nice to get this right before we wrap it.
mhm. So we get r squared minus z squared squared to integrate now. That's, I think, still the same trig sub, but probably different result. I guess let's take the r out like we did the last time. What did we say? We get an r cubed out front.
Let's just
So,
foil it and polynomial. Let's
oh,
just foil. Let's just.
I forgot we can do that. Yeah, that's much easier. The fourth minus 2 r squared z squared. C to the fourth dz. U naught pi omega sigma r to the fourth. Okay, r to the fourth z minus 2/3 r squared z cubed plus a fifth z to the fifth minus r to positive r. This function is
All right.
even, so we shouldn't get 0. What do we get? R to the fifth minus
Minus
2
2/3 r to
thirds.
the fifth plus
Uh,
1/5 r to the fifth.
okay, that it's hard to judge if we're on the right track, but
And that's all the other ones are
uh,
the negatives, aren't they?
well, is that z cubed? I can remember. Yeah, it's z. This one is z cubed, so that this one
Yeah.
flips to positive. And this one is negative. Yeah.
So over
So
50.
we get fraction math.
15 minus 10 plus 3. 18 minus 10, that's 8/15. Ah, I don't think we're getting 2/3. I think we're getting 16 over 15.
That's 2/5. Is this the fraction math that you did?
Um,
2 minus 4/3 plus 2/5.
yeah, basically. Yep.
Dang. We don't have anything out front in the integral that would save it.
And plus, wait a second, we got a pi still out here, don't we? That
We
we're not supposed to end up
do.
with. Yeah, we're not supposed to have that pi.
How do we get rid of the pi? Yeah. I think maybe it needs to cancel out like when we set up I. Oh yeah, that's not right. Um. I feel like we need to say that omega is equal to something involving dividing by pi. I feel like that's where it would come from if we are going to divide by a pi. Um,
I just think our integral is supposed to give us a factor of pi.
I
Oh,
don't.
but how is it gonna come out on the bottom though? You're saying omega, you're saying the pi is supposed to come out of that omega?
Yeah, I'm just worried about using omega itself. I mean, omega does end up in the final answer though. Where does it come from for them? Oh well. If they were current, it's supposed to be just a regular velocity. And so it should be omega like velocity equals omega. Would it be like divided by some? I don't know how you do this. It's something.
I feel like this approach we're trying to use is actually just it's basically like just a different way of doing it, but it should work.
I agree.
I don't think there's like an inherent mistake in the approach.
I agree that using rings feels like it should work. I'm still worried about how we've exactly set up the current, but
Yeah,
I
yeah.
don't know. Angular velocity is weird. I don't remember how it works.
You know, every ring, right? It's rotating with angular velocity omega, which means it's going around, which means, it's going through omega radians every second. Yeah, so V is R times omega, right? So the linear velocity is the radius of that little ring times omega.
Okay.
But
That's
then,
not giving
but
us a
then
pi, I guess.
no, I don't think the pi will come in there unless we want to go from radians to degrees or something weird like that. But I don't think we want to do that.
Um, they just never. They do have a pi. What does their pi cancel? mu naught over... Oh, there's just an inherent pi in the bios of our formula. That canceled for them. And the pi goes away in the version of the formula that will be used for the ring. So maybe we do have the pi in our definition of current, but then maybe right, it has to come somewhere from the integral. I just don't see it. I don't know.
I think if we redid it and we wrote everything in terms of theta, instead of z, we want to write everything in terms of theta. I think then we could get it.
Yeah. Um, there's a couple of small like things in the solution that they're doing with theta that I haven't quite gotten yet, but I think we will be able to get it the way that they're doing it. Or do you think you can still do theta with this ring idea?
Yeah, I think so.
Okay. Um,
Because if I integrate over z, I'm just concerned that those little pieces of the shell I'm taking are not going to be uniform length. Like the closer I get to the North Pole, the longer they get, right? For a
mhm.
fixed dz, as I get further towards the North Pole, I'm taking like big slices. But if my integration variable is d theta, then my d theta always gives me the same size slice of the shell, right?
Yeah. So 2 pi small r
So the circumference is still 2 pi
circumference.
r.
And then the thickness is that it's something d theta. I guess big R d theta?
Yeah. Yeah, there you go. Yeah,
Okay. And
big
then
R d theta.
dq is sigma times that thing.
Yeah,
And if we want to transfer this thing to current,
Just multiplied by omega.
yeah. Except this is where they get an extra. I remember this is the answer. They do get a sine theta coming in the picture, or maybe an r sine theta potentially. But maybe we don't need it with this approach. But I'm a little bit worried about that.
We'll still have to get the lowercase r in terms of a different
In terms of theta
variable, won't we?
Well, we know sine theta
Capital.
is small r over big R. So we can do big R sine theta.
Yeah.
Maybe that's it.
So if that's I times b squared. B squared is our lowercase r squared, so it's going to be another r squared sine squared. Yeah, right?
Yeah.
Yeah, let's try it. Let's try it. We got it now.
All right. Maybe. So theta is minus pi over 2 to pi over 2. We have a... Oh, what do we have? We have a mu naught over 2 r cubed
Mm-hmm.
for the constants. And that's our di times b squared, which is small r squared, which is big R squared, sine squared. Something
And
like
I think
that.
you dropped an omega.
I did.
Yeah, just throw it anywhere.
Yeah. Doesn't matter. Okay, so after the dust clears, we have a mu naught. Still a pi out front, but hopefully that goes away. Sigma, omega. We have an r to the fourth on top, so just an r.
Okay.
The 2's go away. I think I've forgotten any constants.
Looks good.
Sine cubed. I do think they integrated sine cubed.
Yeah, I think they did too.
And this is a much easier
Yep.
one. Because we use Pythagorean identity. And u equals cosine theta, which means du is negative sine theta. Oh my gosh, copy paste, save me. So we get 1 minus u squared minus 1 to deal with the negative sign. Okay. So we get 1/3 cosine cubed theta minus cosine theta. Minus pi over 2 to pi over 2. Yep. Mu naught pi sigma omega r.
Is it working? I think it's working.
Well, isn't this a problem? Isn't cosine of pi over 2 0? Should it be from 0 to pi? It should be from 0 to pi. Because we're dropping theta down from the positive z-axis.
Oh yeah, 0 to pi. Okay.
That would at least get us an answer besides 0.
Hmm.
What am I doing? No, wait, that should be +1. And then cosine of 0 is +1. Uh, well, the pi is still here. We're getting 4/3.
Yeah. Yeah. Plus we're getting 4/3.
We're closer.
We are. We're halfway there. We were out by, what were we out by? 16/9 pi squared, and now we're out by 4/3 pi. We just got to do what we just did one more time, and we'll be there.
I don't know where this other pi comes from.
Are we honestly making the same mistake they said not to make in the book, where it's like, don't slice it up into pieces because it doesn't work?
I think they were doing a different. I think that was a different situation. It's potentially the same error, but at least when I quickly skimmed it, it might have been different. I think you can potentially get into trouble, it seems, but person like they're trying to calculate the magnetic field just outside of a like infinitely close to the outside of a cylinder, and they ended up off by a factor of 2 because they actually got like the average of the inside and outside. But we don't really have that infinitely close issue in this problem. But being off by something that looks like the surface area of a unit sphere or close to it is really weird. I was wondering if there's like an Ampere's law interpretation where if we could draw a bunch of loops around that thing, but it's probably making it too complicated. Oh no, this was a different reason. They actually had to like remove one of the rods because like whatever rod is closest to that point, because it messes up the result for some reason.
All right. Well, now actually, now I'm really puzzled because I thought that was going to fix it.
It nearly did.
Yeah.
We have the same inside of the integral, but well, the constants they shoved outside, they had a 1/2, whereas we didn't have a number out front, and they just had no pi. I think is the only difference. Yeah.
I don't know, so near and yet so far.
Yeah, this is really bugging me.
I think we must still be missing assigned data somewhere. Like,
Even if we were, that wouldn't get rid of the pi, though. Did they, like, hey, Slow Turtle, is there something about the setup of this ring thing that makes it invalid for what we're doing?
yeah, maybe.
Hey, Lucas, what's the difference between math and this? Because it's looking awfully like math. It's physics. It's it, it's weird math. Yeah, so Turtle, feel free to post the problem.
Well, should we shelve this and think about it? Come back to it next time, maybe?
I guess so. It's it's annoying that we're so close, but I might try giving this problem to Google and see if like someone else tried the same way. But that that can be done a little later, I guess.
So how
All
do you
right,
like that Morin Blue Book?
it's pretty cool. I was getting my ass kicked though by I've gone through all the first, or I've gone through the first like two chapters, and I was finding that actually kind of difficult. I do really
Yeah,
like they just give you the bare minimum that you need to know, and then you just get right into it.
yeah, I know. It's good. I like some of the problems are really actually cool. In fact, I was doing some this morning before I started looking at the Purcell book again.
Oh,
And
nice.
yeah, some cool questions. I finished chapter two. I'm in chapter three right now.
Yeah, I'm about to. If there's time today, even I'm gonna get started on chapter three. Um,
I know the idea was speed run it, but I have no idea how to speed run a physics textbook. It's like I could speed run it if I skip a bunch of problems, but I don't know if I should do if I should do that.
um, yeah, no, I'm in the same boat. I'm trying to work through as fast as I can, but I if I'm struggling, I'm gonna work on more problems. So I might end up having to just do every single problem in the book. Hey, Joseph.
What's what's this Alex Jones thing Dr. Cook's
Oh,
talking about?
uh, I didn't want to interrupt because you're like right in the middle of doing an integral or something, but he dropped a link in Twitter apparently about Alex Jones hyping up human progression or something. So I was going to play. I'm kind of surprised that Alex Jones would do something like this, but I'm playing it right now.
All right.
This is just kind of funny to me. There's a part of like I almost want as an alert. It's like it's all math, it's all physics, it's all there. I don't know. Anyway, um,
All right, well, I'm gonna head out and let you do some math.
sounds good. We'll do one more meeting on this chapter, and then the week after will be induction. So, yeah.
Nice.
All right. Thanks for coming out to another group. I'll see you around.
Yeah. Thanks for having it. All right,
Yeah.
see ya.
See you. Okay. Uh, I assume Fembox will still be around, but we're going back into normal like math stream now. Studying. So we got to look at Slow Turtle's question here. So Slow Turtle, I'm just going to be honest. I switch from my title and category to math. Let me do the same for YouTube. YouTube. Where's my title? There's my title. No. Oh no. What did I? Okay. No, I'm good. God, I really like that spherical shell problem. I just wish that our approach worked. Did it get downloaded? It did. Okay, good. Let's get the music playing. What the heck? That's not the image. That ain't it. There we go. Yeah, same. Six per session. Turn to 6.11. Let's see if we can make our parameterization work. Okay. Slow Turtle. Leave. Yeah. That is a small victory. Okay, here we concluded that if the slope of QR is greater than the slope of y equals e to the x at x equals c, it's like a mean value theorem thing. But if slope QR is less than the slope at x equals c, just still intersect at a point before x equals c. Depends how much you're changing it by. Oh wait, it's greater than this. Oh, wait. The tangent? What's the actual original question? The tangent to the curve equals e to the x is drawn to the point c e to the c intersects the line joining the points c minus 1 e to the c minus 1. Twitch chat isn't going through. Oh no. Oh, where these two lines intersect. I see. Yeah, so it's an increasing function, so I think they should intersect beforehand, right? That's the important bit here. If it's decreasing, it would intersect after. If QR is greater than the derivative at C, which happens. Or maybe that's not quite right, the increasing versus decreasing thing, but for here with this graph, it definitely looks like A is the right answer. Um, I've upgraded from Paint. I need to, I didn't set this up before I started the stream though, in typical me fashion. I think it's the same program that Bobos uses now that I think about it, but I haven't really done much with it. Why is it not taking up? What? Why are you not going all the way to the bottom? That's so annoying. I'll figure that out later, I guess. Oh, for the reason it doesn't include the very top of the bar. That's interesting. Regardless. What I mean is, even if the slope of QR is less, it's going to intersect at some point before x equals c. So, yeah, critical. Why is that blue? If that's C, even if the slope was less, they would still intersect before is what you're asking. No, it would intersect after because you basically have. Do I have a line tool in this program? I mean, there has to be one. Draw a line. Surely there's a select tool, right? Hand? Does hand? No, that pans. I gotta get better with this program. Really? I can't like click and drag things? I have to be able to. Ah, there we go. Like, it's really just the idea that if you have two parallel lines, if you tilt one so the slope is slightly greater than the other one, they're going to intersect somewhere on the left over here. But if you do the opposite and tilt it slightly to the right, meaning you're decreasing the slope, but the slope is less than, they're going to intersect somewhere on the right. And I think that's all they're really saying. Is there hockey for this? Right. You know, look at the Discord and see if that's what you're saying. First image has line with slope less than tangent. Second image has line with slope more than tangent. I mean, your drawing is potentially deceiving you here. Why are you drawing them so they're like intersecting? Well, oh, I think I see. Okay, no, never mind. Well, the placement of these things is important though. Drawboard? Hey, Suna. I haven't heard of that one, but I'm not sure I understand like where you're drawing your lines though. They do it just like some random point, but we're asking if that random point is on the left or right of C specifically. I like this program because I can potentially write plugins for it, and I'm interested in trying to do that. It's like open source and all that stuff. So the thing I don't like about your drawing is that you're just kind of drawing like the two lines in a void. I don't really like this coordinate system thing that they have built in. But what we really have is they aren't so free. Like they do have these constraints that I feel like your drawing is potentially overlooking. If I'd actually draw this thing right. No, not you. You stay still. I want you. Something like that. Well, okay, I haven't really, you know, obviously drawing isn't quite to scale, but they're making the argument that if you can actually find the slope of this blue line, if it's slightly more, that means it's tilted up like that. And you just see like the more we tilt it up, they're just going to intersect on the backside there. And if you calculate the slope and find it's less than the slope, that means we tilt it down like this, and they intersect somewhere ahead. What condition would I require if I wanted the line to meet the x-axis such that x is greater than c? What condition would I require if I wanted the line to meet the x-axis such that x is greater than c? So you would want this blue line to hit the x-axis. Like, that'd be a crazy line. Wouldn't it be like that? Because the x, if it's hitting the x-axis greater than c, it has to hit it way out here. Like, that's... maybe that's not phrased quite right, because you'd have to do something crazy with the line. Got beaten by some physics problems. Have to battle that tomorrow. Good luck. Down 4 of hide and seek with the data. Oh god. Hope it went well. So I don't know, still turtle. Does that address your question, or I think I'm maybe not fully understanding what you're asking, but maybe I've gotten the question somewhere in there. I'm keeping an eye on the Discord too in case your internet goes to poop again. Yes? Okay. Finding H in some drop height problems. Oh god. Yep. Alright, so let me bring up criticals then. Find the first partial derivatives. Oh yeah, we can do those. Um, oh, that's not... Okay, that's kind of annoying. U is x to the y over c. So potentially a helpful thing to do is to write u as an actual, or like write what u is a function of. So it's 3 variables. So we need 3 partials. I just wrote 3 when I was saying 3. That's great. Okay. So actually, I should make sure you're here before I start actually explaining it. You are here? Okay, why did I cancel the exponential? I have not canceled anything yet. I've done is like copy down the problem. Sorry if it looks like I canceled. Like my y is maybe a little bit weird. Sorry, no, all I'm trying to do is copying down the original problem here. Binomial theorem? Yeah. So we have 3 variables to take partials with respect to. So let's start with x. So u sub x, so we take the partial of this, we have x on the base, and then we pretend that y and z are constants. So it's just x to a power. And when you have x to a power, you take the derivative, you just do the power rule. So multiply by the exponent, and then subtract 1 from the exponent. So I'd say it's that. U sub y. Now, we pretend x is a constant, and then y is the but before I move on. Y x to the y minus z over... Oh, that's equivalent, yeah. I think the only real difference in that answer is they get a common denominator with that 1. They say that that 1 is the same thing as z divided by z. And so if you do that, you can get x to the y minus z divided by z, like that. Okay. So yeah, moving on to the partial for y. For this one, it's sometimes helpful to make up an example with just like actual numbers, so it looks a bit more familiar. This one is a situation where I would probably do that. So we want the partial respect to y. So for x and z, I'm just gonna put random numbers for now, just so we can like see what it looks like. So let's just pretend that we have 2 to the y over 3, and we want to take the derivative of that. Well, first off, we take the derivative of the like kind of exponential function we have there, and that becomes 2 to the y over 3 just itself times ln of the base 2. But then we do have to worry about the chain rule. So we have to multiply by 1/3, and I ran out of room to do that. So because of chain rule, multiply by 1/3. And so, we can just rearrange this and say what the answer is. But that wasn't the problem we actually had. The problem we actually had was with x's and z's. So let's do the exact same thing, but instead of a 2 and a 3, we have an x and a z. So we start by just repeating the same exponential, x to the y over z, multiply by ln of the base, which was x here, and then because of chain rule, multiply by 1 over z. And you could, it's not all that important, but we can rearrange it to make it look a little bit nicer. You call this nice, at least. That's supposed to be an exponential, it's not quite. Oh god, that's even worse. So I would write it as ln x over z times x to the y over z, but it's not really one clean way to write this, to be honest. Is that one? Oh, okay. Yeah, it is the answer. Sounds good, still turtle. We'll look at it after this. So now for z, I think we should do the same kind of exercise off to the right. So let's do 2 to this time the 3 over z. Because this chain rule will be a little bit different. We start the same way. 2 to 3 over z, ln of the base. Why am I doing it like that? But now the chain rule is a little bit different. We multiply by minus 3 over z squared instead now. And so we basically have our answer here. We just need to, put it back with x and y's. I guess we'll put minus 3. Oops, 3 was y. So minus y ln the base was x. See, I'm getting myself mixed up here with the numbers, which is the downside of doing it this way, but like this. So minus y ln x over z squared times x to the y over z. Oh gosh, what's that? F to the g times f prime g over f plus g to the right way to solve the y? I don't understand what you wrote there. That's a whole mess of f's and g's. So the f is x, g is y over z. Oh, yeah, you could think of it like that. I guess. Well, for y, well, I don't know if you'd want to do like that for y. It depends how you're using these f's and g's, but I don't see how you do that for the y. For the x, I can maybe see that. Um, yeah, I do prefer kind of thinking about this side problem here. If that f and g thing is the same thing though, then I don't see the harm. I just have a really hard time reading that, to be honest. Basically, yeah, that's what I did. Critical. I just kind of chose random numbers that are different. That's probably possible too, still turtle. I bet that that would work too, yeah. Yeah, so that's how I personally like doing it. Critical for when it gets weird to think about. Um, that F and G thing might also work. I just don't see how. I just want to quickly try this partial derivative idea that Still Turtle's saying. Um, what is d dx of ln u? That might be an issue. I don't know how you evaluate that. I should know, I feel like. Or maybe that's the bad way. Maybe that's the bad way of setting it up. Maybe the better way. No, I don't remember. It's weird. Okay, I want to check to see if I got a package yet because I'm expecting a tablet to be delivered today, and I'm kind of excited about it. I'm gonna put my viewer screen for like 1 second, see if I got a package, and then I'll get to Slow Turtles, the problem that they posted. It's not here. I'm sad. It's a Huion something. Oh, what the hell is this? Yeah, that's the other thing that I was wondering about doing that kind of exponentiation. Would that... Okay, well, if we took the partial, e to the y over z ln x times 1 over x times y over z, would that match? Oh, it matches. That's kind of crazy. I don't know the exact name, Still Turtle. It's some Leon thing. So yeah, that would definitely work. I think the other way, taking ln of each side, probably works too, but I don't know. For whatever reason, I just don't know how you do d by dx of ln of u. So when I say I know the binomial theorem, I mean I know like the basics of the binomial theorem. This might be beyond my ability, but let's see. So this is the expansion for well, let's write in the same order. 1 plus x to the 1,000. If you want to be really obtuse and not add the two x's before expanding. Uh, you know, this actually might not be that bad. Because what's the exact statement of the binomial theorem? N choose k. Or no, k equals 0. Oh my god, why am I... Ugh. These exponents are all sorts of wrong. Geometric progression? I mean, I'd rather just use the binomial theorem personally. There might be a geometric way of interpreting this too. It's x to the n minus k, x to the k. Like that. So if we have the x to the 50, that means k equals 50. So it's... Oh, and actually we don't even have n, we have 1,000. So yeah, we need to calculate 1,000, choose 50, I guess. Or well, not even 1,000, choose 50 exactly, but whatever formula they're saying. But yeah, the choose looks like that. And that's actually the lambda mu nu. So lambda is 1,000. 5 mu is the smaller. So 2 times 50 plus 3 times 950. That's not right. How do you get 954? These all end in 0. I am not counting the other cases. Oh, I get it. You're right. Oh, that's stupid. I hate that. But you're right. That makes problems so much harder. The thing that I got isn't even a coefficient of x to the 50. This is something completely different. Never mind. This problem is way harder than I thought it would be. Okay. You have to consider the first 50 terms. Okay, yeah. You're right. Um, so for the first 50 terms, we get one term each, right? And we can probably figure out a pattern for that. Because 1001 choose 951. Maybe. I don't know. I think you're way ahead of me on this problem, to be honest. That produces 1x to the 50th term. This one is, if I set up the exact same way, 1000 choose 950. X to the 50. Oh yeah, and 1000 to 950 is the same as 1000 choose 50. So this one gives us We want the x to the 49th term from this binomial expansion. Like that. So that seems like I feel like I can already see what pattern it is. I don't necessarily know how we're going to calculate it. Ugh. Getting good mileage out of this eraser tool already. So yeah, from that binomial expansion, we're going to want the 48th term. And I could write all these. It's probably more clear if I write them going the other way, or like if I write the other version of the choose. 1,000 choose 50 is the same as 1,000 choose 950. 1,000 choose 49. 1,000 choose 48. Those are all equal. So what the thing we want to actually sum is from k equals 1, or k equals 0 to 50. A 1,000 choose k times 1,000 choose... Oh, infinity. Why did I write... Who wrote infinity up there? 50. I feel like there's a formula for this. This looks very symmetric. Hey, Anders. Maybe looking at the factorial will make this more clear. You got the answer? How's that? You know, I don't think the factorial thing is a good idea. Oh, you like that, Fembox? I don't know how that thing expands, to be honest. How do you know that it matches the thing that we actually have? Oh yeah, and I can rewrite it as NCR. Like that. I don't know how to do that though. I assume arithmetic geometric progression. If you got your answer, that's the important part. I assume there's something to this sum too. I could plug it into Wolfram Alpha and see if it gets the right answer, I guess. How does Wolfram Alpha do choose? I think you just literally just type out choose. Well, that's not right. Now is it? Why is that a... What? That's a little high. Okay, I don't know what's wrong with that, but let me look at what you put. Can I just drag this in? No, I can't. I don't get it. What is this? Yeah, Anders. You'll be right after this question. What are you subtracting in the second line? More Hass diagrams, maybe? I've watched like one or two of their videos, yeah. I'm actually a little bit cold. It's kind of nice considering we just had a heat wave, but I'm gonna go grab a sweatshirt. While you're... Okay. Oh, geez, that sucks. Oh, really, Femvox? It's possible. They did do that sum of rings. Oh, you know what? They I wonder if it's just discrete. Like they did use it for the solenoid, and maybe it's bad to use it for something that's like continuous. Why am I being recommended my own live stream? Okay. I'm glad YouTube's recommending my live stream to someone, I guess. Get a light board? Is he writing backwards right now, or like how does this work? It's kind of trippy. Um I don't actually see what's happening here, but I'll look at it another time. Anders, what's your question? They just mirror image the video after they film it? Oh, maybe. I much prefer to believe that he's writing backwards and is just that talented. Like, context or straight to the question? I guess context? Oh, you sent another one? Um, Sounds good, Anders. Hmm. Okay. Directed set. Oh yeah, I need this definition. With a reflexive and transitive binary relation. Okay, yeah, just with an additional part that every pair of elements has an upper bound. Huh. Okay. And so this has to be infinite, the set? Otherwise, we're whatever you're. Well, I assume it has to be infinite. Okay. If not necessarily infinite. Okay. A set A with binary relation less than or equal to is an ordered set. A and B belong to A, are comparable, are said to be comparable. And note A double bar B if A is less than or equal to B, or B is less than or equal to A. Okay, that means that they're comparable. In the other case, we'd say they're incomparable and note A double bar with a slash B. Okay, yeah. Post it with 3 elements. A, B, C with A less than C, B less than C, but A and B are not comparable is directed. What's the upper bound for... Oh. I guess? It's like an upside down V. I guess you would have a... I think I can see it, where like in your example, you'd have a... Oh my god, dude. Like that. I guess I was thinking it had to be infinite because you would need an upper bound for this pair. So you'd have to go like above with another element D, but then D and C would need another upper bound. But I guess that's not the case. C's an upper bound for A and C. Okay. I guess, yeah, they don't say it has to be distinct. I think I understand these then. Given a directed set A, you know, if I put text down and then I click away, can I come back and edit this? I can. Okay, good. This font is... What is this font? Why is it starting narrow and getting wider? Oh, this is... I hate... I just hate... how do I change this? Surely. There's... Oh, sans regular... Okay. It is true that I'm done with the large proof I'm dealing with. Okay. Given a directed set A, we define X to be all X and A such that X and Y are comparable for all Y and A. So basically, does there exist an element in every directed set that is comparable with every other element? That's the idea. Hmm. Well, it seems like every pair of elements having an upper bound is going to be maybe helpful. Yeah, exactly. Because maybe it seems like something that we would. I don't know if it's. Well, maybe it's not quite a perfect contradiction, but like suppose. I mean, I guess it is that X is empty. Yeah, that intuitive explanation makes sense to me, Anders. No, I'm just like trying to figure out what my attempt at a proof would be for this. Um, well, maybe we don't need to suppose X is empty. Man, yeah, how to put this into words? Because What would it mean if you have a directed set without an element that is comparable to every other element? Yeah. Well, but no, your like little ABC example, A and B weren't comparable, but we still had an upper bound. But that um it does feel like in that scenario, if we have like if not every element is comparable in a directed set, I feel like the top of it would have like multiple peaks, like like that. When these things would be the not comparable things, but that would make it not directed, right? Because then where what upper bound would exist for these pairs, like for like that pair. Can't have an isolated element. Yeah. It feels like we should be able to construct this element that would be an X. Like, let A and B belong to A, and A and B be not comparable. Not be comparable? It's be easier to write. Because actually, this thing can do LaTeX, but I feel like that'd be potentially slower. Oh, you can't even see the little window that pops up, but I want to see if I can use, like, the first thing I want to try is see if I can use the LaTeX thing that this thing has and letting people in chat provide input into it. I think that'd be kind of cool. But trying to make Twitch chat talk to this thing is what I gotta figure out. I think I have an idea. Since A is a directed set, there must be a C such that A is less than or equal to C and B is less than or equal to C. A and A. If A and X, then we're done. If not, it means there is some B and A. That might be a better start. Yeah, like we want to get... Yeah. And like, I guess here, like, since A is a directed set, there must be a C in A such that A is less than or equal to C and B is less than or equal to C. And like, here's where I want to say, like, hence, either C is in X, or if C is not, oh, not capital C, is not in X, then repeat the process. As well. I don't know if that counts as a proof, though. Proof by cumbersome notation, Tertar says. Ugh. Like that's what I would want to say here. If there was anything that process is finite. Maybe that's the issue. It's false? Is there a counterexample? You'll draw it? Okay. Hmm. I'm imagining how, like, you would if this thing is false, you'd have to like imagine, like, if you have two peaks that seem to not be comparable, you would, remind whoever that this is a directed set and that these two things have to have an upper bound. But then if it's not possible, you'd have to always find some other peak over here that you have to then compare it with, and then another peak over here, and then another peak, and, like, I guess an infinite amount of peaks off to the right. That's the only thing I can imagine. for like always being able to find another peak needing to compare it with. There. Okay, this is actually a different way of the exact thing that I was imagining. Yeah. Um, so I was trying to come up with an actual example of this, like maybe like involving like powers of primes or something, but I don't quite know if I did powers of primes, how I would make that through line there. Even then, how would I compare them? That's not a very well formed thought, I guess. So like I every time naming an actual set and comparison that would achieve this, divisibility can you don't think divisibility can generate that diagram unless we ignore some elements. Do you agree that A is directed? That this thing is directed? Yeah. For any pair of elements, there's a pretty clear upper bound, I would say. Hmm. For any element, we have others in the same horizontal line. Yeah, this really makes me feel like prime numbers should be involved somehow. I have a hard time saying it if we wanted to find an example of such a directed set. That means x is... Wait, for any element we have others in the same horizontal line. Right, yeah. Proof goes to the trash. Yeah. That sucks. Okay. I don't know if this will be a valid directed set, but I feel like my idea for how you can make this is like Damien, thank you for the follow. A is a prime number to a power where P is prime. K is an integer and 1 is less than or equal to K is less than or equal to P. I know this is going to be really valid, but we could define our comparison, I think, as like like what I want is for this like, you know, spine here to be 1 to the 1, 2 to the 2, 3 to the 3, 4 to the 4. And then figure out whatever the comparison has to be to make the rest of this stuff work. I'm not saying divisibility. I'm thinking some weird rule for comparing these that has different cases. Because we only want things with the same base to be comparable unless K equals P. And that's what I'm trying to... Let A and B belong to A. A equal P1, K1, B equal P2, K2. Something like if P1 squared with 2 index, you can't see the prime powers. Okay, yeah, if you have your own example, then like you should probably do that. But if P1 is, oh shoot, no, there's maybe a little bit too many cases than is going to be convenient. See you, Suna. Thanks for hanging out. Something like lexical order for pairs ij with I less than or equal to j. Oh, that's an interesting thought, Poingelis. Are these might just be my cases right here, I guess. I don't know if this is really a valid definition though. there's a lot of here that there's a lot of things here that I'm kind of like making up. So I'm not very experienced with sets in general, much less sets, but and even less with directed sets. But part of reconstruction just makes me think of prime powers, so I think that'd be my best swing at it. But that index idea looks interesting. Opposed to the index thing. We define aij to be less than a and m if and only if I equals j is less than or equal to n equals m, or I is less than n and j equals m. Right, where I is the row, j is the column. Okay. I think that's basically a way simpler version of my prime power thing. So I wasn't really using the actual values of the primes as much as I was using their placement. So that's probably just a better version of my idea. Because you don't really need them to be prime. Wow. All right. I don't know that I could contributed much, but nicely done on that, Anders. Um, I might wrap up the stream soon, but is there anything else before I might do that from anyone? Let's race through the more in blue book. That could be fun. How long is the chapter 2? Oh, no, it's like 3 pages, dude. This had to be so hard to condense all this material down into not even 3 pages, 3.5 pages. Thank you for the question, Anders. Oh, we're already getting into rotational motion. I mean, I haven't read the little thing, but I could be. What's like the first question here? Wait. Oh, okay. Man, I don't know. This might be a little bit too complicated. I don't know if I want to look at it right now. Well, I've seen this exact problem before for 3.1. Isn't it the same time? Bullets fired horizontally from gun, and the bullets simultaneously dropped from the same height. Which bullet hits the ground first? They hit the ground at the same time. I'm like 99% sure because they both accelerate the same amount vertically. And just because their x velocities are very different doesn't affect that. Yeah, you'd have to ignore the air resistance and curvature of the Earth, I guess. Got it right? Okay. This is, well, I kind of wish that before we did the reading group today that I read this part. I might have had a slightly better idea for, I might have felt slightly more comfortable with the Omega. Wait, no. We're still not getting a pi. Never mind. I gotta get that out of my mind, at least for a little bit. Probably try and finish up chapter 3 tomorrow? Okay. You're probably gonna beat me then. I should try and do this before I stream next on Tuesday. Just try and get through it quicker. But we'll see. I think okay, yeah. I think we'll wrap things up here then for the day. Might just play Tomb Raider. Ooh, is there like which Tomb Raider are you playing? Was there a new one? I feel like there's a new one maybe in the last like few years. I think we're up the stream up here though while we're talking Shadow of the Tomb Raider. That is a relatively new one, right? So anyone's here on YouTube, like Territar, I appreciate you being here as much as you are, and anyone else who's here on YouTube, thank you. I do plan to stream again on Tuesday, so hopefully see you all then.